This one is a little bit more of an opinion than anything else. Claire and Han are discussing how to find the missing lengths. Claire says she is using similarity and Han says he is using the Pythagorean theorem. Do you agree with either of them? Show or explain your reasoning. So we know from the angles, we can see that this has a 90-degree angle and this has a 90-degree angle. And we can also see that this angle here is congruent to this angle here. So by angle-angle similarity, these two triangles are similar, which means that we could set up a proportion to find the missing side lengths in each one of these. The other way that we can figure this out is by doing the Pythagorean theorem. So if I were to use similarity, I would want to find this length right here. I would start by doing x, because whenever I set up my proportions, I like to start with whatever I'm looking for. And I know that x is going to correspond in the other triangle with 6, so I'm going to do x over 6. And then I have to come back to my original triangle, and I can pick either one of these two, but it has to have a corresponding side in this triangle. So I have to use 5 because 5 corresponds with 2.5, 13 corresponds with an unknown side length, and I can't have 2 unknown side lengths in a proportion. So I can do 5 over 2.5. And so we're just going to cross multiply. So 5 times 6 is 30, and 2.5 times x is 2.5x. And so we're going to divide by 2.5 on both sides to figure out what x is equal to. And so we get that x is equal to 12. So this length right here is equal to 12. The other way that I can check to see if this is correct is by using the Pythagorean theorem. So remember, this is a leg, this is a leg, this is the hypotenuse because it is opposite from the 90-degree angle. And in the Pythagorean theorem, we know that a squared plus b squared is equal to c squared. So leg squared plus leg squared equals hypotenuse squared. Doesn't matter which one we put for a and which one we put for b, as long as they're both legs. C always has to be the hypotenuse. So if I were to take these 3 numbers here and plug them into this formula here, it should be a true statement. So 5 squared plus 12 squared is equal to 13 squared. And I'm just going to put a question mark up here to show that I'm just checking to see if this is true. I know 5 squared is 25. I know 12 squared is 144. I know 13 squared is 169. When I add these two together, I get 169 is equal to 169. That's a true statement, so I know that this is the correct side length for this triangle. I can do the same thing for this other triangle over here. I can use the Pythagorean theorem, or I can use similarity. So I could do, we'll call this one y. We'll do y over, now y is the hypotenuse here, so it needs to correspond with the hypotenuse over here. So y over 13 is equal to, now I have to come back to this triangle, and let's do 6 over 12. So 6 over 12. I know that 6 and 12 go together because x is 12 over here, so I have 6 and 12 go together. So I'm just going to cross multiply again. Y times 12 is 12y, and 6 times 13 is 78. So we're going to divide both sides here by 12. And I should get y is equal to 6.5. So this length up here is equal to 6.5. Now, if I was going to check my answer, I could use the Pythagorean theorem to check my answer. So again, a squared plus b squared is equal to c squared. Again, I have a leg, and the hypotenuse. The hypotenuse is always c. So, and it doesn't matter which leg I put where. These can be a or b. So we have 2.5 squared plus 6 squared is equal to 6.5 squared. And again, I'm going to put the question mark up above just to show that I'm checking this. So if we take 2.5 squared, we get 6.25. 6 squared is 36. and 6.5 squared is 42.25. 42.25. It's a little dicey there. All right, so if we add 6.25 plus 36, look at this, we get 42.25, which is equal to this number up here. So it means that we can either use the Pythagorean theorem or we can use similarity to solve for those side lengths. So this one we've already done on the previous page. We know that the length of AC, that was our y. So here we have that y is equal to 6.5 AC. And then x was our value down here for the length of DE. And so our length of DE was 12.